So this presentation is a little bit, of course, related to the previous ones, but I think it's a little much more primitive because the shape set which it affects is much more simple. But I still hope that it is more or less obvious, if I'm able to start it, why is it important, or why do I think it's important. If you have a landscape like this, I think it jumps out simply that it is an interesting and geometrically important shape that you should understand, at least if you want to speak about this landscape. So this, the top of the tower itself is called Spire. Maybe it's not known for everyone. It's a steeply pointed termination to the tower itself, but it has, of course, some ideological meanings, of course. There are some specifications about which spire shape should be named how, but there are only a few definitions, and they usually contradict themselves. I will come to that point later. So in this case, I simply want to show a very simple specification or an analytic rule which helps us to combine or create these types of spire shapes. Actually, I use it in our classes, and it turned out that even it looks very simple, in very many cases the students find it not too simple to create in a CAD program. So we haven't got any automated way of creating these spire shapes yet. We use the students to provide it, or myself, because I create these examples for them. This is not spare parts, it's spire parts. I think the most important thing is that if we have a gable, it is usually connected with the spire apex itself, but as this figure shows, it's not a necessity. You can choose whether it's connected or not. You will have the opportunity to create these shapes as you like them. First, I wanted to find the basic spire shape set, which can hold or show the primitives that later can be used or in themselves, or you can combine them to get more complicated elements from them. This is a familiar landscape, I think, for everyone. So in the Mediterranean area, you can find very simple solutions. If you have a square base, you put a simple four-sided pyramid on the top of it, and that's it. So it can be the first case. It is, I usually use this sign. Simply the A means a regular pyramid, and 4 is for the number of sides it has. The next step is a little bit more interesting. If you grab this midpoint of this horizontal edge and move it upwards, then a break will appear which connects the apex of the gable with the apex of the whole shape, spire itself. And of course, you can move it into whichever height you want, but there's a regular height, let's say, for it. Then, if you cut this shape with a horizontal plane above the apex of the gable, of course, then you can get a regular octagonal section. So that is a specific height, of course, and it sets the regular height of this shape. Of course, you can use lower or higher gable heights also. And the next step forward is when you move this midpoint even a little bit higher, and this way, this ridge which was connecting the corner of the base with the spire apex disappears. It simply sinks into the plane. And this way, again, you have a four-sided pyramid above a four-sided base. This can be done, of course, over any number of sides. So if you have an octagonal base, of course, you can have an octagonal spire on the top of it. It can be very simply modeled by simply connecting the two neighboring gable edges with a plane, and it will show you how high this shape should be. And next step forward is to raise these midpoints even higher. And the only difference in this case that the section, the horizontal section of this primitive object becomes concave, and the basic setting is the same, but of course it's much tougher to build. Probably that's the reason why I only found German examples for this shape. No one wants to spend so much time building such a simple shape, or I don't know any other reason why. And of course the final step is to reach the height of the spire apex itself. When the gable and the spire has the same height, of course you will get a gabled roof simply. And theoretically, of course, you can move it a little bit further up. I didn't find any existing example of that, but on a previous picture I saw that maybe this very spire looked different in the past. I don't know for sure. It's an interesting question. So we have a basic spire shape set. Of course, it's not all these elements. You can have as many sides as you wish. And what is important that in all cases, in the regular cases at least, you have a specific ratio between the height of the gable and the spire apex. It is written here, but it's not important for us right now. What is important that it is a specific ratio, so whenever you set the type of the spire you are using, you set the ratio between the height of the gable and the spire apex. And then you can start combining these shapes with each other. On the diagonal, the A, the C, and the E versions are shown. And of course, you can union or intersect them like in any Boolean operation or any CAD program that is capable of Boolean operations. Of course, when you use only the basic shapes, then all the shapes are often transformations of each other. I mean, if they have the same sign. But when you start combining them, then even the same shapes can result in different results. So we have to add the new parameter to specify or to be able to distinguish between the two, for example. Let me point out that in this case, both shapes have an octagonal, regular octagonal section. So if you want, in this case, you can put a square-based spire, or in both cases, you can put an octagonal spire on the top of the original shape, if you want. So it's more or less obvious that you cannot find a specific name of all possible spire shapes. So you have, or you need a notational system. And of course, if there was a CAD program that would be capable of using these spire shapes or these primitive shapes as its own element, these are the potential attributes a very simple shape should have. So in the top part you see the basic settings, of course, the number of sides, or the inscribed or circumscribed radius, and the spire type, of course, can be selected from a list, and you have the opportunity to set the angles of either the gables or the spire apex or the height of them. What makes this thing a little bit more complicated than it looks, then of course all the parameters can affect the other. So if you want this small program to work flexible, you need a much more sophisticated decision tree than you might think for the first look. And of course, to avoid confusion, it should remember your previous choice. So for example, if you set the height first for the apex, then you change something somewhere else, you wouldn't wait the program to change this very setting. It should change something else to meet the requirements. So this is a very simple graph showing that When you want to decide the base, you can set the number of sides and the inside or the circumside radius. That's very simple, of course. And you can choose another pair of parameters from the top graph. Usually, we prefer to set the type, of course, because that's the most obvious and by the user it is the most important setting that it can be specified. But of course you can choose other combinations also. And what is also important that of course there are some pairs that cannot be used together. So for example, if the type is A, which is a simple polygon, then you don't have gables, so there's no point in setting either of these parameters because they are obviously 0. So it will not help you to draw the spire shape itself. Then you have to change something else. So again, it's a very simple program, of course, but still it's capable of drawing elements. And why is it important? Why, usually there are two types of problems, or they can say that it's not important enough. I think this landscape says that it is important to understand these shapes. Then the other question is that, okay, it's all common knowledge. Everyone who looks at it will understand, and there's no point in saying such complicated things about such simple elements. I think it's not the case again, because when you try to describe these spires, you meet problems. So first of all, this is a typical English landscape. The broad spire has a name and has a correct definition. It's the exception, not the rule. But if you change something, you simply rotate this top part. You don't have a name for this type of shape anymore, and it's not even clear that it can be called a broad spire or not. And you can find similar shapes in real. So it's just not for recording. So it's very easy to say that, okay, on Wikipedia, of course, there are plenty of people writing anything they want, but if you look around, you can find that there are plenty of definition problems. So for example, in this page they are saying that the brooch, or this split foot spire, is simply a variation of the brooch spire. I think it speaks much more about the country where it has been created. In England, there are plenty of these spire shapes, and they said that, okay, this definition with a little bit more extended use, it can be applied. The problem is that, of course, you have plenty of more choices, more possible geometries that can be used that way. But it's still straightforward relative to the next one. If you want to find the definition for the helm spire, if you can read it for yourself, I think, what is obvious that the description tells that this is the regular shape of this spire, but the only example it mentions will take you to the Spire Cathedral, which is obviously a different shape. So you don't know whether you should believe what you see or what you read. The next one is here. It's a very exciting shape. You cannot build it in 3D, but otherwise it's exciting. It's a combination of the two. And in the two appearances of the same dictionary, you can read four-faced steeply pitched roof using gables, and then you have the picture of it, which displays nothing of these. So, a short summary. This analytic description I propose, I think, will help or can help the better understanding of the geometrical logic and the morphological and historical connections. So if you have words to describe these specific attributes of the spire shapes, you can describe that a given shape is often used in a specific region of the world. The same way, the same way, the more precise classification can be used either for educational purpose, also for the history of architecture, but I think, as we have done, it is useful in geometry and the CAD. So you can ask the students to create a spire shape with specific settings. So, for example, the angle between the horizontal projection of this edge should be exactly 30 degrees from the front face, and then they have to find out how can they create, or how they can meet this criteria. And it can be used, of course, as a simple construction tool. So if you have the opportunity to create your own spire, or at least to design one, you can try to figure out what are the rules that usually applied for them. Theoretically, you can have as many spire shapes as you want, but of course, tradition, practice, and aesthetics will limit the choices. I think I'm out of my time, so thank you very much.